Number 9, we're looking at y equals e to the 1 over x. And where this might be potentially discontinuous is, well, the e function is generally continuous, but as we let x go to 0, we're going to be looking at 1 over x function. And again, the 1 over x function, if you recall, approaching 0 from one side looks different than approaching 0 from the other side. So there's this potential for a discontinuity for 1 over x as x approaches 0. So as I write my limit in, x is going to approach 0 from one side of e to the 1 over x. And this ends up being equal to e to the 1 over 0 from the positive side. And that means that that's going to be e to the 1 divided by 0 is infinity. So it's going to be infinite. From the other side of 1 over x, we end up with e to the 1 over 0 coming from the negative side. And that ends up being e to the negative infinity. And this will, any power to the negative infinity is equal to 0. It'll tend towards 0. So when we look at the graph of this, it's approaching the asymptote from this side, and it's probably approaching, well, it is approaching 0 from the y equals 0 from the other side. And there it is. So the graph is going to have some sort of look something like that as it approaches 0. So it's discontinuous. It's an infinite discontinuity. For number 10, it's a log function. I'm going to do this in different colors so we don't get confused. The log function has a vertical asymptote. In this case, the vertical asymptote is going to be where log of 0 is going to be at -1. And this graph is going to look like that. It's going to have a vertical asymptote here. So again, this one has an infinite discontinuity at its start point.